Today we're talking about the concept of concavity. Now, concavity is something that is most likely going to be new for a lot of us here in this class, but it really is something that is pretty intuitive. We just have to see examples of it. Now, we've been talking the last couple weeks about rate of change. And we found, rate of change is how our function is changing. We saw that we can use y2 minus y1 over x2 minus x1, or f of b minus f of a over b minus a. We can use those two formulas to help us find rate of change. But what happens when we see the rate of change in a function? The last several classes we've been talking about what makes a function linear. And we have seen that linear functions have a constant rate of change. And that's why they have a linear shape. But most functions we've seen in the past aren't linear, like in Algebra 2. You'll see functions with crazy shapes. I can draw a couple of them here. You can see like a function like that, right? And that's definitely not linear. In fact, most functions have rates of change that change as x increases. And here are two examples, x squared and negative x squared, that we can use as an example. So let's look at these two functions, and we see that, well, first, this question's asking us to find the average rate of change from x equals negative 2 to x equals negative 1. So we can do y2 minus y1 over x2 minus x1. And in this case, our x1, we can say, or our x2 can be negative 1, and our x1 can be negative 2. And then we want to find those corresponding points on our graph. So negative 1, we go up. I see that's positive 1. Minus, well, then from negative 2, we go up. And I see that that is positive 4. 1 minus 4 would give us negative 3. And negative 1 minus negative 2 would give us positive 1. So the rate of change here we get is negative 3. Okay, so we've seen that before. And then the next question is asking us to find the average rate of change from x equals negative 1 to x equals 0. So let's see what happens there. For this one, I can do the f of b minus f of a over b minus a. I'm going to say this is b and this is a. Well, if we do this, we want f of 0 minus f of negative 1 over 0 minus negative 1. F of 0, that's just going to be 0 squared, right? Because if we look up here, our function is x squared. 0 squared minus negative 1 squared over 0 minus negative 1, which is just 1. 0 squared is 0, negative 1 squared is 1, so there's going to be negative 1 over 1, which is just negative 1. Interesting. So we go from a rate of change of negative 3, and then it becomes a rate of change of negative 1. So I see that it's becoming less negative. It's increasing. Okay, so we can find one more, and I'm not going to talk it through. I'm just going to work it out and show you the work. So now we're going from negative 3 to negative 1 to 1 as x is increasing, because x goes from negative 2 to negative 1 to 0 to 1. What trends do you notice in the rate of change as x increases? Well, I'm seeing that as x is increasing here, the rate of change is also increasing. So as x increases, the rate of change increases. It goes from negative to positive. And so that's what we're seeing happening here. And we can draw this visually. Let me pick another color so we can look at this. And I'm going to get rid of, oh dear. And I'm going to get rid of these things I drew up on the board. Okay, there we go. So let's look at this function and let's think. Well, we can draw a slope that connects the line or the points we were talking about. From negative 2 to negative 1, that's from here to here. the rate of change talks to us about slope. And so we're seeing, okay, there's that slope. It's super negative. And then from -1 to 0, from here to here, this slope, well, it's less steep. And then from 0 to 1, we have this line going like that. And now it becomes more positive. So this one was super negative. This one was less negative. And now this one is more positive. And so again, we're just seeing on the graph what we're seeing in our rate of change here. We're seeing just that the rate of change is increasing. Now, that is true for this function, but let's see if that's the same thing that's happening for the function on the right. I'm going to give you a moment to try to work out the rate of change here. This function is y equals -x squared. So try to find these rates of change, and then I'll fill them in. And so now what we're seeing is kind of the exact opposite of what we're seeing on the other side. So I'm going to use a different color here. Here on the left, we saw that the average rate of change was increasing as x increased. But here we start off at 3, but then it becomes 1, and then it becomes -1. We see instead for this function, our average rate of change is decreasing as x increases. As x increases, the rate of change is decreasing. I'm going to say it decreases. And so this idea of the rate of change changing introduces a new concept for us called concavity. And here, when our rate of change was increasing, this shape, we call this concave up. And over here, and we can remember it because it looks like a cup. And then if it looks like it's facing downward, this is concave down. And we're going to define those in a moment. Here we have, as x increases on a given interval, so from one value to another, if the rate of change of a function is increasing, like we saw earlier, then the graph is concave up. But then if that function is decreasing on the interval, we say, like we saw above, the graph is concave down. And then if it's neither increasing or decreasing, then the graph is neither if the rate of change of the function is constant, then the graph is neither concave up or down. And so let's see this in action. So we can look just informally, and when we say informally, for concavity, we just mean the shape of the graph. So is it looking like this or is it looking like this? But then to do it formally, we have to look at the rate of change, just like we did before. We have to look at the rate of change at each interval to see what's happening. Here, in this function, we're looking at a business manager's salary in thousands of dollars as a function of time. And we're given a graph, and from the graph in general, it looks kind of like it's facing up, right? Not facing down. And so we can say this might be concave up. This might be concave up. But in order to prove it, we have to look at the function's rate of change. And so at the bottom here, I see the rate of change, or I see there's a place for me to write the rate of change, and I can say, oh, as this changes by 10, this originally changes by 32. So our rate of change is 32 over 10, which is 3.2. But then the next 10 years, plus 10, this changes by 56. So now our rate of change is 56 over 10, which is 5.6. Then again, we change by 10 years. And again, we see an increase in our change, this time by 102. So we get 102 over 10 equals 10.2. And so here I can see that as our t increases, as it goes from 0 to 10 to 20 to 30, our rate of change keeps increasing. And so, because the rate of change increases, what does this tell us about the graph? What does this tell us about the function? It tells us this function is concave up. And here we have another example, and I want you to just take a guess as to what you think it might be. Is this going to be concave up or concave down just by looking at the graph? Just by looking at the graph, it kind of looks like it's concave down because it's like an upside down cup. But then we want to test the rate of change. I want you to take a moment to try to figure this out. What are the rates of change? As you can see here, our rate of change starts at 20 miles per hour, and then it goes all the way down to 7. And so since we have a decreasing rate of change, what that tells us about the function is that this function is concave down. And to end out this video, we're just going to look at what different types of concavity look like. Here, we see a function that's increasing, right? And we've talked about what it means to be increasing or decreasing. It's increasing, but it starts increasing by a lot as we go up here, and then it slows down. When it slows down and it makes this downward shape, this is an increasing but concave down function. Here's an example of a function that's decreasing and concave down. On the left, we see a function that is decreasing, but it starts off decreasing by a lot, so very negative. And then the rate of change becomes less and less negative, so this is concave up. And it kind of looks like an up cup. And then this last one is increasing and concave up. For today's practice, you're going to go through and you are going to make some decisions on whether or not some graphs are concave up or concave down. And then you're also going to use a table to determine whether or not the function is concave up or concave down based on its rate of change, just like we did here.